All right, we're in section 6.3 now. We've already talked about multiplying and dividing rational expressions. Now let's start to talk about adding and subtracting. Now we're going to start off kind of basic, where all of our problems in this section will have common denominators already. Because if you recall, when we add fractions, we need to have a common denominator. Remember, if I have 2/3 plus another 1/3, that really gives me 3/3. Or I can reduce and say 1. Do you notice that they already had common denominators? And I keep that common denominator where I just add the numerators together. 2/3 plus 1/3 is really 3/3. We don't say 3/6, right? All right, that works the same way with rational expressions. If I have 5 over 2x plus 3 over 2x, as long as I have a common denominator, I can add those two fractions together. I can keep their common denominator of 2x and just add their numerators. So 5 over 2x plus 3 over 2x is really just 8 over 2x. Now, can I reduce it? Is there a common factor that I can reduce out of 8 and 2? Well, it looks like I'm able to divide both of those by 2. 8 divided by 2 is 4, and 2 divided by 2 is 1, and I still have an x left in the denominator. So my final reduced answer would be 4 over x. So remember, anytime I'm adding, I need to make sure that I have a common denominator. I keep that common denominator, and I just add the numerators together. Let's do a few of those. Example number 1 asks us to add and simplify. So remember, as long as I have a common denominator, I can add my fractions together. Let's keep our common denominator, and then let's just add our numerators together. So 4 over a plus 3a plus a over a, I keep my common denominator, and I add my numerators. So on my numerator, I have 4 plus 3 plus a. Or really, can I combine like terms and say I have a 7 plus a? That's my numerator, and my common denominator is still just my a. Now be careful, I can't reduce the a from the top and the a from the bottom unless I can reduce an a from all three terms. But because that 7 doesn't have an a with it, remember they're connected with the plus or minus sign or parentheses to keep them protected. And if I can't reduce a factor from everybody, then I have to just leave it like that. So that's my final answer. Look at B. I'm adding two fractions, and it looks like they already have a common denominator. So let's keep that common denominator, and let's just add their numerators together. So my common denominator would be the 2x plus 1, and then my numerators added together would be my 2x squared plus 3x minus 7 plus x squared plus x minus 8. And now I can combine like terms. I have a 2x squared and a 1x squared, that gives me a 3x squared. I have a 3x and a 1x, that gives me a 4x. And I have a negative 7 and another negative 8, that gives me negative 15. Now, can I reduce this any more than it already is? Well, let's see if we can factor the numerator and factor the denominator and see if there's any common factors that I can reduce. It looks like the top might be a bottoms up problem. When I bottoms up, try to factor it with bottoms up, I ended up factoring it into an x plus 3 and a 3x minus 5. You might have to do that off to the side to double check if that's right. The denominator is already factored into a 2x plus 1. You notice that there is no common factor between my numerator and my denominator, so I would just have to leave it like that. So really this would have been an acceptable answer because there's no other GCF or factors that we could factor. But you wouldn't have known that unless you actually factored it out. So I highly suggest you factor it, and you can leave it like this too if you need to. All right, let's look at C. I'm adding two fractions together, and it looks like they already have a common denominator. So I should be able to keep that common denominator and just add the numerators together. So I have an x minus 5 plus 2. Or really, can I combine like terms and say that I have an x minus 3 on the top? Now, do you notice anything? It looks like that denominator can be factored, can it, into a difference of squares? So I should be able to take that x squared minus 3 and factor it into an x minus 3 and an x plus 3. Did I say x squared minus 3? I meant 9. X squared minus 9 can be factored into an x minus 3, x plus 3. And you notice the top and the bottom both have a factor of x minus 3. So can I reduce an x minus 3 from the top and bottom? Now be careful. There's an invisible 1 in front of here. So the top is still there. There just happens to be a 1 left over an x plus 3. So sometimes factoring helps us reduce it even more. It didn't necessarily help us on B, but it did on C. So it's important to do it every time just in case. All right, in the next video, we'll talk about subtracting.